In a previous video, we talked about cis and trans isomers, and I mentioned at the end of that video that we can't use cis and trans to designate all stereoisomeric alkenes. And in more complicated cases, we have to go to the E and Z designations, and that's what we're going to talk about in this video. So, in order to have cis and trans isomers, we need to have the same group on each of the carbons connected by the double bond. And in this example, right, this carbon has an ethyl and a fluorine and a hydrogen and an NH2, and so because I don't have the same group on the two carbons, I can't say whether that same group is on the same side or different sides, and so I can't use cis and trans to differentiate between these two diastereomers. So the first step in assigning these E and Z designations is to assign priorities to the groups attached to the carbons connected by the double bond. And we do this based on atomic number. And so assigning these priorities is exactly like assigning the priorities when we designated RNS configurations. So if you need help on assigning the priorities, I would recommend going back and watching that video. So in this case, the fluorine gets priority over the carbon. And so, right, that would be the highest priority, that would be the lowest priority, and then the nitrogen gets priority over the hydrogen, so I have priority 1 and priority 2. And then once we have the priorities, we assign the E and Z designations. If the highest priority groups are on the same side of the double bond, then that's designated Z. And if the highest priority groups are on the opposite sides, then that's given the designation E. Now, the Z and the E both come from German words. It's Z when they're on the same side, E if the highest priority groups are on opposite sides. Now, I had a hard time remembering which ones were E and which ones were Z, and so I can't take credit for this. I Googled and went to some student forums, and the best idea for remembering these that I saw was someone recommended remembering this, right? Z is the same side, right? So Z when they're on the same side, E when they're on opposite sides. And so I say this little phrase in my head whenever I'm assigning these. I don't say it out loud because I don't want to sound silly, but this helped me to remember them. All right, so if we want to assign the E and Z designations to this alkene, the first thing I need to do is assign priorities. So first we'll look at this carbon. Right, and it's attached to an oxygen and a carbon. Oxygen has the higher priority, so we have a 1 and a 2. And then on this carbon, right, we're not showing the hydrogen, right, but it's obviously going to have the lower priority than the carbon. And so the 1s are on the same side, the same side, right, so this alkene is Z. All right, here's another example. When I start with this carbon, it has an ethyl and an ethyl. And so I put this example in here on purpose to remind you that just because we have a double bond doesn't mean we have cis and trans or E and Z stereoisomers. In this case, because I have the same group on the same carbon, right, this compound is not stereoisomeric. So it's not cis or trans or E or Z. All right, here's one more example. When I look at this double bond, right, I've got two hydrogens, right, so this one isn't E or Z, and so we're focusing on this double bond. When I assign the priorities, right, I've got carbon and carbon, so I need to see what it's attached to, right, this guy's attached to an oxygen, the highest atomic number that this one's attached to is a carbon, so this is going to have the higher priority, so I've got 1 and 2, and then when I look at this carbon, right, I've got CH2, CH2 again. Then I go to this carbon, right, it's attached to just one other carbon. This one's got the double bond, so this one's going to have the higher priority. And so now the highest priority groups are across the double bond, right? Z is the same side, right, but E is the opposite sides. So this is going to be the E.